The addition of vectors means we're looking at what happens when two forces act on the same object. So, for example, say we're given this vector v and w, as you can see, and we have this point, any point that we're going to say both of these vectors are going to act on this point. So what that means, we'll do v in blue, essentially if the point starts here, v is going to push the point up and to the northeast. So that's our vector v, and then we also have w acting on the object. So w is going to push the point straight towards east. Now notice w is a little bit longer, which means it's going to push the point further in that direction. Then v will be up to the corner. So the resultant, which is what it's called when you add the vectors together, is the movement the object actually makes. So you'll notice if the blue and green both push that point in their directions, in reality that point is going to move somewhere in between, so more towards that purple arrow. So that's one way to draw it. That's kind of number 2 on the slide, where you draw both vectors from the same point. Their sum is the vector that occurs between them. So this is the vector v plus w. Now it's a little hard to see where that purple vector might be. So here's where we have number 1 on that slide. And this is kind of the easier way to think about vector addition. So that's where if we're trying to do v plus w, so again we have our point, v plus w, we'll draw v first. So v goes up to the left, and then from the end of v, we will start with w, and it will go straight over. So notice I just drew v first, and then I added w to the end. The resultant is the vector that goes from start to end. So we started at the pink dot, we ended at the end of the w vector, the green vector, and that would be v plus w. You can work with this either way because addition is commutative, meaning the order can change. So v plus w should be the same as doing w plus v. So we could draw the same thing. We start with our pink dot. We could do our w vector first, so over to the right, and then we could add the v vector up to the left. Notice if I drew these perfectly and took into consideration the slope and all that, either way that v plus w in the end should look the same. Notice it looks to be about the same slope, about the same length. So vector addition is when you have two forces acting on the same object, and the answer to these in all 3 of these cases is that purple vector, and that's called the resultant.